Good day and welcome to another interesting lesson. In this lesson, we are going to learn how to use logarithm to evaluate given expressions. Now let's note that in using logarithm to evaluate expressions, we will be doing addition, subtraction, multiplication, and division of logarithmic values. So let's take notes. We begin by looking at addition and subtraction of logarithms. So look at this first example here. You don't see any strange thing here. I mean, the normal counting numbers we know. Let's come to the second example. You observe that 5 here has a bar. What does the bar mean? The bar means the 5 is a negative number or a negative value, and it affects only the 5 and no other number. Unlike in this situation where we have -3 in front of the whole value, the negative here affects all the digits in the value, and so this negative is different from the one which is used as a bar on top of a particular number. Example is the 5 here, as we see. I hope you understand it. Okay, so now let's go ahead and look at how we will solve these examples. So let's begin with the first one. We have 6 plus 8. That will give us 14. So 4, remainder 1. So the remainder 1 will add to 5, making it 6. 6 plus 6 is 12. So 2, remainder 1. So 4 plus 1 will be 5 plus the 1 here, which will give us 6. There is no remainder, so 3 plus 2, that is 5. Then we have our decimal point here. 2 plus 3 is also 5. I believe this kind of calculation is very familiar. Let's come to the second example. 6 plus 4 is 10, so 0 remainder 1. So that will make this side 8 plus 5, that will give us 13. So we write 3 remainder 1. So here becomes 4 plus 4, that will be 8. 4 plus 8 will be 12, so 2 remainder 1. Now the remainder 1 will add to the 2 here, making it 3. 3 plus -5, that will give us -2 as the answer. So this is what happens. You see how we treated the bar? It is -5. Okay, let's come to the next example. You have 3 plus 1, that will be 4. 6 plus 9, that will be 15 remain. So 5 remainder 1. 5 plus the remainder 1 will give us 6. Plus 3, that will be 9. Then we have 6, 4 plus 6, that will give us 10. So 0 remainder 1. And we have our decimal point here. Now when we add the 1 to -3, that will become -2. We are adding +1 to -3. That will give us -2. So -2 plus -4, that will be -6. You see how we did it. Now let's move to the next one. We are still doing addition. 5 plus 6 is 11. So 1 remainder 1. 4 plus 4 plus the remainder 1. So that will be 9. 6 plus 8, that will be 14. 4 remainder 1. 3 plus 2, that's 5, plus the remainder 1, 6. Then we have our decimal point. We have negative 2 plus 7. That will become positive 5. Then we come to the next example, where we do subtraction. 5 minus 6. That one, we need to borrow 1 from the 4. That will bring us to 15 minus 6. That will be 9. So here we are left with 3 minus 2 will be 1. Here we have 7 minus 8. So we need to go and borrow 1 from the 3, making it 17 minus 8. That will also be 9. Then we have from the 3, it is now 2 because we have taken 1 from it. And so it has become 2, then minus 1 will be 1. Then we have negative 5 minus 3. So negative minus a positive number, that will become negative 2 negatives, giving us negative 8 as the answer. So the next example, we have 5 minus 6. That is also impossible. We borrow 1 from the 4. 15 minus 6 is 9. So here we are left with 3 minus 2. That will be 1. 7 minus 2 will be 5. 3 minus 6 will not be possible. So we need to borrow 1 from the negative 7. Now here, let's take note. It is negative 7. We remember when we borrow 1, we subtract 1 from it. So negative 7 minus 1. It will no longer be negative 7, and it will become negative 8. Note, we have subtracted 1 from it. However, that 1 that we have taken, when we bring it to the 3, it will not come as a negative number. It will come as a positive number. So here we will get it as 13 minus 6. Yeah, that's what will happen. It will become 13 minus 6, and that will be 7. So we have our decimal point here. Remember, we said here is negative 8 and not negative 6 or negative 7 again. So negative 8 minus negative 4. Something like minus 8 minus negative 4. Remember that the negative here will cancel this one, and then you will have it as negative 8 plus 4. I hope you know this one. So negative 8 minus negative 4 will become negative 8 plus 4. And that will give us negative 4 as the answer. So this is how we do addition and subtraction of logarithmic values. Multiplication and division of logarithms. We are going to multiply this as usual, the normal multiplication we know, and then afterwards we do the divisions here. Okay, so let's go on. So 4 times 6, that will be 24. So 4 remainder 2. 4 times 0, that will be 0 plus the remainder 2. So that will give us 2. 4 times 8 will be 32. So we write our 2, remainder 3. And then we are adding the 3 to the result we get for 4 times 5, which is 20. So 20 plus the 3. That will be 23. So 3 remainder 2. We have our decimal point here. 4 times negative 1 will be negative 4. So negative 4 plus positive 2, that will give us negative 2. So that is the result of this multiplication. Then we move on to look at the division. So we take our first example, 4 with a bar, 0.9425, divided by 3. Now what you need to take note of is that the negative value here should, when we do the division, should give us a whole number. So what we should understand is that we can rewrite this expression as 4 plus 0.9425, and we are dividing them by 3. So we are working as if we are acting on them separately, but not entirely. So I have to rewrite the 4 bar such that when I divide by 3, the result I get should be a whole number. And so I'm going to write it as 6 bar. What it means is that I have added negative 2, and I need to add positive 2 to neutralize this development. So I'll put plus 2, then 0.9425. So this is what I have done to make sure that when I divide the number with the bar by 3, I'll get a whole number as a result. So here, when I do the division, I'm going to get negative 2. So 2 bar point, or maybe I'll say plus 0.9808. So when I put them together, it becomes 2 bar point 9808. So that is how we do the division of logarithmic values. Then the second one, 2 bar point 4110 divided by 3. We are following the same concept. So what I'm doing now is I'm going to include negative 1, which will give me 3 bar plus 1.4110, and I'm dividing by negative 3. I hope this is understandable. Okay, so when I divide the 3 bar, I'll get 1 bar, and then plus. So when I divide the other one, I'll get 0.4703. So I put them together, and then I'll get 1 bar point 4703 as a result. So this is the result. And then for this one, this is the result. Okay. Then the last example, 4.1958, also divided by 3. Now this one, they are all positive values. So we just do straight away, we do the division, whatever value we get, that is what it is. So when I divide 4.1958 by 3, the result is 1.3979. So that is it. Okay, so now we have looked at addition, subtraction, multiplication, and division of logarithmic values. So what we have to do next is to put them together to do the evaluation that we actually aim at learning to do. Okay, so in this example, we have 45.32 multiplying, so it's a fraction and the numerator is what I'm reading. So 45.32 multiplying 3.546, and the denominator is 39.47. So this is the question, and let's see how we go about it. We are using logarithm. So let's say log of the value given, 45.32 times 3.546, and then we are dividing this by 39.47. Okay, so it's just one value. Let me put it in the middle. 39.47. So you are using logarithm now. Is that not so? Good. So this time, let's apply the laws of logarithm that we know. We have the numerators multiplying, and then there is a denominator. When there is a fraction, what do you remember? So this one will become log of the numerator. So 45.32 multiplying 3.546, and then we will have to subtract. That is the division law. So subtract log 39.47 from it. And then even this one, we are going to also use addition because it's multiplication. So it becomes log 45.32 plus log 3.546, and then minus log log 39.47. I hope this one is not anything strange. We are supposed to use logarithm. That is why we have introduced logarithm. And we are using logarithm to break it down, to simplify, and then to get a final answer. So I hope this is okay by you. Good. So here we have to find the log values of each of them, and then we do the addition and subtraction as required of us. Okay. So let's take our calculators. Log 45.32, that will give us 1.65629. So I'll end it at 4 decimal places, so 63. Then we are adding this to log of 3.546, and that will also give us 0.5497 minus log of 39.47. That gives us 1.5963. So this is what we have. And now we can do the addition and subtraction. It's very simple. Okay, so now let's do the addition and subtraction. That gives us 0.6097. Now we have to remember that the value we have is a log value, but the question actually was not a logarithm question. It's just we are only employing the service of logarithm to arrive at the answer. We are just using log. And so once we are done using log has given us its final answer, we are supposed to convert this. So we need to find antilog of the results we've got, so that then we do away with the logarithm and then come back to our normal values. So we need to find antilog of what we have. So when we find antilog of the value, we will get 4.0709. Okay, so I can approximate and it will become 1 0. So this is it. This is how we use logarithm to evaluate an expression. It's very simple, isn't it? Um, so we can also use a logarithm table, which I will be using more than even going through like this. This one is for you to understand that even if you are using the table, everything we are doing is just following these steps or these formats, but just in a tabular form. So with the table, we write the number and then we divide here and say the logarithm. Let me use a different color. We divide it and then we have our logarithm. So this is our log. So the first number is 45.32. Now 45.32, if you convert it to logarithm, you are going to get 1.5 1.6563. So I have done an approximation. So it should have been 6562899012, but I have approximated. So the next value is 3.546. So if you are to find the log of this number, we are going to get 0.5497. You remember? Okay. Now remember that these two numbers make the numerator, and we need to, because we are using logarithm, we need to add the multiplying values. So because they are multiplying, we add, just as we did here. So the two numbers will be added. Okay, so we find the sum of the two, and that will be 7 plus 3, which is 0 remainder 1. 6 plus 9 will be 15 plus the remainder 1, that will be 6 remainder 1. 5 plus 4 will be 9 plus the remainder 1 will be 10, so 0 remainder 1. 6 plus 5, that will be 11, plus the remainder 1, that will be 12, so 2 remainder 1, and that will be added to this one, and that will be 2. So when we do the summation, we get 2.2060. Then we come to the number which is the denominator, which is 39.47. So this one too, by logarithm, we will get 1.5963. And this one will be subtracted from the numerator. So the numerator has already been simplified. So we are subtracting the log value here from it. So we do the subtraction. So we are subtracting 1.5963 from 2.2060, and that will give us, so this one we borrow 1 from the 6, 10 minus 3, which will be 7. Then it's now 7. So now 5 instead of 6. And so we can't do the subtraction here. We borrow the zeros 2 does not have. We will go ahead and borrow from here. 2. We added the 1 to the 0 becomes 10. We take 1 from there, we bring it here. Now we have 15 minus 6, which will give us 9. So the 0 here is now 9. Minus the 9 here will be 0. Then the 2 is no longer 2 but 1. So we also borrow another one. It becomes 11 minus 5, and that will be 6. And then here will be 1 minus 1, which is 0. So the subtraction has also been done. Now, once we are done with the subtraction, we need to find the antilog because we have done the simplification. And so we find the antilog. and that will be antilog of 0.6097 will be 4.0710, and so that's our answer. This is how we do it. It's very simple. In the subsequent examples, I'll be using the table because the table is very simple. And so just look at how the steps that we follow in doing the normal one, and that is the same thing we do when we are using the table. Now we take our next example. As I said, in this example, I'm going to go straight to the table. So I have my table here like this. This is the this is the number, and then its logarithm values or logarithmic value. Okay, so the first number we have 57.34. We are to convert this to logarithm. If we convert this to standard form, our exponent 10 will be 1. So 1 point. Then we find a mantissa. Okay, so log. So this one will be log 1.7584. Okay, so I'll run it as 85. That is for this one. Then the second one, 0.6572. Now, if we are to convert this to standard form, 0.6572, it will become 6.572 times 10 to the power negative 1, right? So the negative here becomes our characteristic. So our first characteristic is 1 bar. And then we find the mantissa. So the mantissa, we get it. So it's going to be 0.8177. Okay. Now look at the numerator. They are multiplying. So in logarithm, what do? We add them. Okay. So we find the sum of these two numbers. And that will give us 5 plus 7 is 12. 2 remainder 1. 8 plus 7 is 15. Plus remainder 1 will be 16. So 6 remainder 1. 5 plus 1 is 6. Plus remainder 1, 7. 7 plus 8 is 15. 5 remainder 1. That gives us this side to be 2. 2 plus negative 1 will become positive 1. So that will be the sum of the numerator. Then we come to the next set, which will be the denominator. So we have 97.28. So this one will give us 1.9880. And then the next one is 0.067. So this one too, as I illustrated here, I will get 6.7 times 10 to the power negative 2. So it means that my characteristic is negative 2 points. Then I find the mantissa. and I'll have it as 8261. Okay, so this is split, and remember the denominator is also made up of two numbers multiplying, so we also sum them, and that will give us 1 plus 0, which is 1, 8 plus 6, which is 14, 4 remainder 1, 8 plus 2, 10, plus 1, 11 remainder 1, 17, so 18, 8 remainder 1, and here it will become 2 minus 2, which will give us 0. So this is what we have. Then also remember that in logarithm, if you have log a over b, it should become log a minus log b. And so this is the numerator, that is this one that we have here. And then the denominator is what we have here. So it's like a and b. So what do? We subtract the denominator from the numerator. I hope this is a simple thing. Good. Let's move on. So we are now going to do the subtraction. So we subtract. We are subtracting 1 from 2. Uh, so 1 from 2 will be 1. And then 4 from 6 will be 2. 1 from 7 will be 6. 8 from 5 is not possible. We are going to borrow 1. So 15 minus 8 will be 7. Here is 0, here is 0. So that ends it. So 0.7621. Then that is it. We have done the subtraction. So with logarithm, we've seen the final answer. But without logarithm, what's our answer? So let's take antilog. So we are taking antilog of the value we have. So we find antilog of 0.7621. That gives us 5.7823 as our final answer. So that's it. Use logarithm to evaluate these values. Okay. So we start with the first one. I'm going to create my table. So the original number and its log value. So I have 0.099. So if I'm to find the log of this, I will have to convert it to standard form. That will give me 9.9 times 10 to the power negative 2. And my characteristic will be the 2 bar here. So I have 2 bar point. Then I have to find my mantissa, which I get 9956. Okay. Now, if you look at the value given, you see that it is squared. So in logarithm, the square will drop to multiply the log value. So here we are multiplying by 2. And we have already looked at how to do multiplication, so I'll go ahead and give you the result. So that is 3 bar dot 9912. Okay, so with this done, we have to find antilog because we only use log to find what we are looking for, we need to get rid of the logarithm in it. So in converting this to antilog, remember that 3 bar is the power, that is the characteristic, is the power of the exponent of 10. So this one is 10 to the power negative 3. And we are multiplying that by antilog of the mantissa. So antilog of the mantissa, so that gives me 9.799. So this is what I have. So when I multiply this, I'm going to get 0.009799, and that is the result obtained for the first example. Then for the second example, let me use the space here, and because of that I will use a different color. Okay, so the number is given and its log value here. So we have 1.013. We are converting this to logarithm. It's already in standard form, and so it means that it is just times 10 to the power 0. So our characteristic is 0 point. Now we also find the mantissa. So I get 0.0056 as the log value, and when you look at this, you see that it is to the power 100. And so if it is to the power 100, what it means is that we are going to multiply by 100. So we are going to multiply by 100. So 100 times 0.0056, and that will produce 0.5600. Okay, so that's what we have. And so now we need to find antilog. So we find antilog of what we have. And that will give us 3.631. Okay, so that's how we do it. Evaluate the following using logarithm. Okay, so we have this. So I'm going to draw my table. The number here, and then its log value here. So I have 56.23, and when I change this to logarithm, I'm going to have, to standard form, I'll have 5.623 times 10 to the power 1, and so my characteristic becomes the 1. So I have 1 point. Then I need to find my mantissa. So that gives me 7500. So when I find the log of this, I get that. Okay, now when you look at the expression, we have a root. So log of a root number, let's say a, we can rewrite it as log of a to the power half, and the half will have to drop to multiply the log value. So like this. So which means when you multiply, it's going to be something like log A divided by 2. So the log value we have obtained, we are going to divide by 2. So we are going to have 1.7500 divided by 2, and that gives us 0.875. Okay, so that's what we have. Now, when that is done, it means that we have worked on the number. We've used log to do our part. So now what we have to do is to find antilog. And when we do, we remember that 0 is 10 to the power 0. So it's just 1 multiplying antilog of the mantissa. So that will be 7.4990. So when we multiply this by 10 to the power 1, it still remains 7.4990, and that is the result. Evaluate the following using logarithm. Okay, so we go ahead and solve. We have our number and then the log value. So our number is 455.3, and if you convert to standard form, we get 4.553 times 10 to the power 2. So our characteristic is 2, and then our mantissa, that will be 6583. So 0.6583, that's what we have. Now when we look at the expression, we see that it is to the power 1/3, and in logarithm 1/3 will drop to multiply, and when it multiplies, just the numerator times the value and divided by 3. So we are going to divide by 3. So we have 2.6583 divided by 3, and that gives us 0.8861. With this, we are done with the logarithm aspect, and so we need to get rid of the log to come to our normal value. So we find antilog, and when we do, we will get 7.693 as our result. We are to evaluate the expression under the square root sign, 23.56 multiplying 66.45. Okay, so we do it. We have our number here, and then we have the log value. So we take the 23.56, and when we convert this to standard form, we are getting 2.356 times 10 to the power 1. And because of that, our characteristic will be 1 point. The mantissa, so the mantissa is going to be 3722. 3722. Then we take the second one, which is 66.45. That one, so we get 1.8225. So that's what we get. Now, when you look at these two, we realize that they are multiplying. So in logarithm, when a and b are multiplying, we separate them as log a and then we add it to log b. So what we are going to do is we are going to add the two values that we have obtained. So we add, and when we do, we'll get 3.1947. Okay, now let's also remember that whatever we have here is under the square root sign. What it also means is that it is to the power, so we have everything here was to the power half, so the half will drop to multiply them, so the result that we get will be halved, and that means that we are going to divide by 2. So 3.1947 divided by 2. Since they are all positive, the division will be straightforward. Okay, and that the result will be 1.5974. That is what we have. Then our next task is to find the antilog of what we have. Yes, so we are done with using the logarithm to do the calculations that we need, and we need to get rid of the logarithm so we come back to our normal value and its result. So when we find antilog of 1.5976, we are getting 39.57, and that is what we have. Okay, so we have another example where we are to evaluate the expression under the fourth root of 0.09476. Okay, so we go ahead and solve. Our number is here, and then the log value. So we have 0.09876. Now, before we can find the characteristics, we need to convert this to standard form. That would be 9.876 times 10 to the power minus 2. So that our characteristic becomes 2 bar point the mantissa, which you will get as 9946. Okay. Now, after we have found this, let's remember that it is log of a value which is under the fourth root. So we are going to now change the fourth root into a to the power 1 over 4. And this 1 over 4 will drop to multiply log a. I hope you understand this. So now we are going to multiply the log that we have found by 1/4. And that means that we are dividing by 4. So what we have here is 2 bar point 9946 divided by 4. Now, do you remember when we were learning the division of logarithmic values? We said if the characteristic has a bar, Then when we do the division, it shouldn't give us decimal value. So with our 2 bar plus 0.9946 that we have, we are going to write the 2 bar as 4 bar, and then we neutralize the negative 2 we have included by adding positive 2 to the other side, so that when we add, it gives back 2 bar 0.9946. So this is what we are going to now do the division on. So when we divide 4 bar by 4, we will get 1 bar. So 1 bar point, then it continues at 7487. So that's what we have after we do our division. Okay, so now after we've done the division, what's next? We need to find antilog. That's where we've got to. So we are finding antilog of what we have. Okay, so in finding antilog, we remember once again that the characteristic is made up of the power 10, the 10 power. So it's 10 to the power negative 1. And then we are multiplying this by the antilog of 0.7487. And that will be 5.607. That is the antilog of 0.7487. And when we multiply by 10 to the power negative 1, we are getting 0.5607 as our result. So the antilog is 0.5607. I hope this is understandable. Okay. So we are to evaluate the product of these three values. So I will start by creating my table, the number, and the log value. And the first number is 3.807. It's already in standard form, and so my characteristic will be 0. And then my mantissa will be 5806. Then my second number, which is 186.4, if I convert to standard form, I'm going to get 1.864 times 10 to the power positive 2. And so my characteristic is going to be positive 2.2704. And then the third number, 0.00375. If I convert to standard form, I'll get 3.75 times 10 to the power negative 3. And that my characteristic is 3 bar. And then my mantissa is 5740. Okay, so in logarithm, when you find the log of three numbers that are multiplying, we separate them with addition. So it's going